Hi, hello everyone. Welcome back to my channel. So last class we are studying shear force and bending moment diagrams. So far we completed the what are the notations we use. That means what when we use positive sign, when we use negative sign in shear force and bending moment diagrams. So and we studied the types of loads and we completed different types of cantilever beams. So different types of beams we completed like a cantilever beam, simply supported beam, so continuous beam. So it's like that overhanging beam, like that we completed. So for that cantilever beam, so now we are going to study the cantilever beam. That means here see cantilever beam with the point load at the free end. So in a cantilever beam, so one point load that is at the end. So at that time we want to draw the shear force diagram and bending moment diagram for this type of information he given means. So cantilever beam with point load at a free end. Not only we can draw at a free end, wherever if we, not only at free end, we can draw here also. We can draw here also. Wherever we can draw. According to that, we want to draw the shear force and bending moment diagram. So according to the question, we want to draw this question. So cantilever beam means they give informations load and distance he given in question. He will give in question. Don't bother about that. So now we want to derive how it will be there. So now first of all we want to draw the shear force diagram. For that shear force diagram is we want to consider only load here. So we should not consider the distance. So only load. So how much load it acting and this point, that is the only shear force. So now see shear force at point B. So first of all after drawing this one we want to divide this section. That means exactly center we want to draw a section XX line. So after that from the right side, so we already studied at right side the load is coming from top to bottom. At that time we use a positive sign. So this is a positive. The shear force at point B, C, we want to give these notations A, B, C like that. So A, B. Now we want to find the shear force at point B. At this point we are finding the what is the shear force. So at point B is we want to consider only load, not any distance. So for that plus W. So if there is in place of W there is a value that is load, that means 20 kilonewtons or 40 kilonewtons, that one like that. So just we want to write here plus 30 plus 20 the value in the form of positive. So because right side is acting downwardly, at that time we use a positive. Last class we discussed that one. So next shear force at point section XX. So section XX plus Wn only, because there is no force, only one force in the entire this length is acting W load only. So after that it will be point A. See shear force at point A. Now we are finding the shear force at point A. We completed at point B and section XX. So next point A. Here we are acting same load only, positive, because there is no another load. So if it is acting there is a one load here, at the time this both loads act on the point A. So because only one point, no, for that only Wn only. That means 20 means here, so plus 20 only. So shear force at point A also plus 20. So that is shear force. So next coming to the bending moment diagram we want to draw. So first of all we want to divide the paper half. So one side is meant for drawing diagrams and another side is meant for writing this calculation. Or else you can first of all calculate the calculation and afterwards we can draw. So either we can use procedure. So I think it is better. So that means one side is diagram and another side is matter. So next after that we want to draw the shear force diagram. So shear force diagram. So see at point B what is load, how much it is positive, how much. Next first to take a reference line, and make a line one horizontally from horizontal point to the whatever the length he given. That means we have W length here we have. So we want to take a W newtons, or else we can he get a 20 here, means we want to draw the up to 20. So approximately we can draw. So by showing difference. So next the point at A. So at point A also W only. So there is no any loads other than point load. For that entire this is a horizontally, that means constant line we want to draw. And next it is a, we want to close this, so same length in both sides. So this is a shear force diagram of cantilever beam with point load at a free end. So next bending moment diagram. So bending means force into distance. So now this is a diagram. So point B, at point B here, so minus y we are indicating. So we already studied that means when it is in clockwise direction. So when it is clockwise direction, that means here it is moving in like this clockwise direction. At that time it is a negative sign. Clockwise means negative here. So we studied in last class. So is at point B is distance is 0, not x. Understood? So 0 means force into distance is 0. It is not moving. So for that W into 0, 0 newtons only. So next bending moment at section XX. Now see the section XS. Then here it moves from point B to the section XS. How much distance means x distance. That means load into distance is how much for the section XX? X distance. That is W into X. See here minus W into X. Why? Because minus means we already studied in last class. So it is moving in clockwise direction. Minus W X. That because minus Wx only. So next bending moment diagram at point A. So at point A what? So load, that means W only. So W into distance what? L distance from see the length how it is. L distance W minus W into L. So minus W into L. This is the bending moment at point A. So now we want to draw. So at point B we have 0. Force into distance is 0. That means load into this moment is 0. For that we want to make a one point here. That means first of all we want to draw a one reference line, and then point it is 0. No, from that we want to draw. So at section XX we have W minus WX. So minus WX. So for that we want to draw the, so above means positive, below means negative. So for the diagram becomes downward side. So we want to draw the negative. That means downward side minus WX this length. Next we want to draw the at point A. At point A is minus W into L. So we want to extend the line. According to the lengths we want to show the difference here. Not accurately, so approximately. So then we got a minus WL. So we completed the bending moment diagram and shear force diagram here. This is the procedure for all the types. So for simply supported beams we want to find the RA values and RB values. So supports we want to find, and then we want to draw like this only. So this is a way to solve. So thank you for watching this video and continue the next class so for understanding. So thank you.